Hello, my name is Albert Ramirez. I am from Harmony School of Innovation, and my PBL is on black holes. So what is a black hole? How do we know they exist? A key model that helps one wrap their mind around black holes is the gravity well. A gravity well is a pull of gravity that a large body in space exerts. The larger the body, the more of a gravity well it has. As you can see in the diagram, our planet has a small gravity well compared to the Sun, whereas the black hole has a deeper well than any other celestial body found in space. By creating a gravity well, my partner and I were better able to understand how a gravity well works. As you can see, the large ball in the middle of space creates a deep well in the plane. Let's pretend this is the Sun. Since our Sun is extremely dense, it will create a deeper gravity well than any other planet in our solar system. As you can see, the marble entering the Sun's gravity will make a few turns around the Sun before being pulled directly towards the center. Our planet orbits the Sun just as the marble orbited the larger ball. This does not mean the Earth will be pulled into the Sun. Our planet is moving sideways compared to the Sun at around 2 miles a second, so we aren't moving fast enough to escape the pull of the Sun, but fast enough to not be pulled into the Sun. When applied to a black hole, things act differently. No known object in space can escape the grip of a black hole. In order to escape its pull of gravity, an object would have to exceed the black hole's escape velocity, or in other words, the speed of light. Gravity wells can be escaped. A certain speed that has to be met to escape a gravity well is known as the escape velocity. As you can see in this demonstration, the small marble escapes the gravity well of the larger object. We can see this in foreign objects that enter the orbit of the Earth. There are many objects that have entered the pull of Earth's gravity and have escaped to their high velocity. Comet P 2016 BA14 is one such object that flew past Earth on March 22, 2016. At the time of its closest approach, the comet was about 2.2 million miles away. But how do we know black holes exist? The only way black holes can be identified is by studying the effects they have on the space around them. For example, when matter such as gas or dust or even a whole star comes too close to a black hole, it is drawn towards it. Matter spiraling in towards the center of a black hole heats up to millions of degrees before plunging into the center. Gas this bright glows in X-ray light and can be seen in an X-ray telescope. Another way to identify a black hole is to look for jets of matter that tend to shoot out of black holes. Since black holes are the only known source for these jets of matter, it isn't hard to understand why these jets are a fingerprint for black holes. The idea of black holes was first introduced by John Michell and Pierre-Simon Laplace. Their idea was that a star of sufficient size and density could prevent light from leaving its surface, creating a dark star. This theory was ignored by many, but resurfaced with Albert Einstein's expanded version of the theory of relativity. Known as general relativity, it could provide the theoretical basis for black holes. Many more astronomers and mathematicians will develop theories and ideas that culminate to the discovery of black holes. Carl Schwarzschild proposes that enough matter packed into a small enough space could have such a powerful gravitational field that not even light can escape from it. We also have mathematician Roy Kerr showing that massive stars will drag the space-time around them like water swirling around a drain. Kerr's equation was discovered to only apply to black holes. Eventually, the black hole is the name given by John A. Wheeler to describe collapsed stars. This has been Albert Ramirez. Thanks for watching.